In the next step, I will summarize the lecture. In this lecture, we found out the radius of this circle, and we actually used two rules. The first rule is that the central angle is twice as big as the peripheral angle resting on the same chord here. This is the rule. The central angle is twice as big as the peripheral angle resting on the same chord. So here we have the peripheral angle ACB that rests on chord AB, and the central angle AOB. This angle also rests on the same chord called AB. Therefore, according to this rule, the central angle AOB equals to 2 times the peripheral angle ACB. So angle AOB equals to 2 times ACB. And also we use the second rule, that is the law of cosines. So in any triangle, here this triangle ABC could be any triangle. We know that the length of side AB equals to A units, the length of side AC equals to B units in its length, and finally the length of side BC equals to C units in its length, and this angle BAC equals to theta. Then, according to the law of cosines, in this triangle ABC, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Again, C squared equals to A squared plus B squared minus 2 times A times B times cosine theta. Okay, and from this equation, it is very easy to arrive to this equation, that cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Okay. So we defined the center of this circle as O. Then we joined points O and B together. By certain time we joined points O and D. We joined points O and A, and finally we joined points O and C by straight lines. So those 4 straight lines, OB, OD, OA, and OC, are the radii of this circle. Why? Because they starts from the center of this circle, that is to say from point O, and that's at any point on this circle. This is exactly the definition of radius. So they are all equals to the radius of the circle. We define the radius of the circle as capital R. Therefore, OB equals to OD equals to OA equals to OC equals to capital R. Okay, then we focused on chord DB. This chord DB, we have this peripheral angle BAD that rests on chord DB. So we define the peripheral angle BAD is x over 2. Therefore, the central angle BOD that rests on the same chord BD must be equal to 2 times x over 2, that is x. The next step, we focused on chord AC. On chord AC, we have this angle CDA that rests on chord AC. So we define this angle CADC is y over 2. Therefore, the center angle COD, this angle that rests on the same chord called AC, must be equal to 2 times y over 2, that is y. Okay, in the next step we implemented, and then in the next step, actually we focused on the straight line AB. On the straight line AB, we have this angle is equal to 45 degrees. Therefore, Then we say again here, and again DEA must be equal to 135 degrees in its length. According to rule number 1, that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the upper side of the straight line AB at point E, we have 45 degrees plus the missing angle in total must be equal to 180 degrees, so the missing angle must be equal to 135 degrees in size. Okay? So then we focused on the pink triangle, triangle AED. On the pink triangle, triangle AED, we know that the sum of the angles in any triangle equals to 180 degrees, and especially in this triangle, triangle AED. So which angles we have here? We have x over 2 plus y over 2 plus 135 degrees equals to 180 degrees, according to the rule that I mentioned. Yeah. The pink triangle AED, x over 2 plus y over 2 plus 135 degrees must be equal to 180 degrees. We subtracted 135 degrees from this equation and found out that 180 degrees minus 135 degrees equals to 45 degrees, and it is equal to x over 2 plus y over 2. We multiplied this equation by 2 and found out that 45 degrees times 2 is 90 degrees, and x over 2 times x is x, y over 2 times y is y. So in conclusion, found out that x plus y equals to 90 degrees. Then we subtracted from this equation x and found out finally that y equals to 90 degrees minus x. Okay, then we implemented the law of cosines on the green triangle, triangle OBD. According to the law of cosines on this green triangle, triangle BOD, cosine x equals to r squared plus r squared minus 2 squared, which is 4, over 2 times r times r. I repeat again. In the green triangle ODB, according to the law of cosines, we get that cosine x equals to r squared plus r squared minus 2 squared, that is 4, over 2 times r times r. So cosine x equals to r squared plus r squared is 2r squared, minus 4 over 2 times r is 2r squared. Then we split this side of the equation to 2. So cosine x equals to 2r squared over 2r squared minus 4 over 2r squared. Okay, so 2r squared over 2r squared is 1, and here we have 4 over 2 is 2, so in the denominator we have 2, in the denominator we have r squared. So in conclusion, found out that according to equation number 1, cosine x equals to 1 minus 2 over r squared. Then we implemented the law of cosines in the yellow triangle, triangle AOC. On the yellow triangle, triangle AOC, according to the law of cosines, we get that cosine y equals to r squared plus r squared minus square root of 2 squared, that is 2, over 2 times r times r. Repeat again. In the yellow triangle, triangle ACO, the triangle ACO, cosine y equals to r squared plus r squared minus 2 over 2 times r. So cosine y equals to r squared plus r squared is 2r squared minus 2 over 2 times r squared. Then we split this side of the equation number 2 to 2 parts, and we got that cosine y equals to, the first part is 2r squared over 2r squared, minus, and the second part is minus 2 over r squared. So cosine y equals to 2r squared over 2r squared is 1, and here we have 2 over 2 is 1, so in the denominator we have 1, and in the denominator we have r squared. So it is in total 1 over r squared. So in conclusion, we found out that according to equation number 2, cosine y equals to 1 minus 1 over r squared. Then we defined 1 over r squared as t, and then we substituted 1 over r squared by t in equation number 1 and equation number 2. So in equation number 1, we have cosine x equals to 1 over minus 2 over r squared. So it is minus 2 and 1 over r squared is t, so it is 1 minus 2t. Okay. So further we found out that according to equation number 2, cosine x equals to 1 over cosine x equals to 1 minus 2t. Then we substitute 1 over r square in this equation number 2 by t. So we get that cosine y equals to 1 minus 1 over r square is t. So it is cosine y equals to 1 minus t. Okay, here we got that cosine y equals to 1 minus t. So, and we have already found out that y equals to 90 degrees minus x here. So we substituted y by 90 degrees minus x. So here we have, again, we already found out that y equals to 90 degrees minus x, so we substitute y by 90 degrees minus x. So we have here cosine y, and y is 90 degrees minus x, so it is cosine 90 degrees minus x. And we have the trigonometric identity that cosine 90 degrees minus theta equals to sinus theta. Therefore, cosine 90 degrees minus x must be equal to sinus x. So in conclusion, we found out that cosine y equals to sinus x. Cosine y equals to sinus x. Therefore, we can substitute cosine y by sinus x in equation number 2. Okay, and we get that cosine y is sinus x, and it is equal to 1 minus t, and according to equation number 1, cosine x equals to 1 minus 2t. Okay, we used the trigonometric identity that sinus square theta plus cosine square theta equals to 1 in those two equations, in the expressions of sinus x and cosine x. So according to this trigonometric identity, we get that sinus x equals to 1 minus t. Therefore, sinus square x equals to 1 minus t squared plus cosine square x, cosine x equals to 1 minus 2t. Therefore, cosine square x equals to 1 minus t squared, and it is equals to 1 according to this trigonometric identity. Then we opened the brackets here and found out here that 1 minus t squared equals to 1 plus 1 squared, that is 1, plus t squared minus 2t. Opened also this the brackets in this equation, and we found out that 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared, that is 4t squared, minus 2 times 2t, that is minus 4t, that is equal to 1. So here we have 4t squared plus t squared equals to 5t squared. Minus 2t minus 4t equals to minus 6t. And finally, we have 1 on both sides of the equation, so 1 will get cancelled, and we're left with 1 here in this side of the equation. Is equal to 0. So in conclusion, found out that 5t squared minus 6t plus 1 equals to 0. 6 minus 6t equals to minus 5t minus t. So we substitute minus 6t by minus 5t minus 1t, and we got that five t squared minus 5t minus t plus 1 equals to 0. Then we took out 5t as a common factor from those two expressions. So inside the brackets, we left 15 minus 1, Then we took out a common factor of -1 from those two expressions. So inside the brackets we left with t minus 1 that is equal to 0. Then we took out t minus 1 as a common factor from those two expressions. So inside the brackets we left with 5t minus 1 that is equal to 0. So here we have two solutions that are possible for t. Either t minus 1 equals to 0, and the second solution is that 5t minus 1 equals to 0. So we start with the first solution, t minus 1 equals to 0, so t equals to 1. And according to our definition, t equals to 1 over r squared, so we substitute t 1 over r squared, and we learn that 1 equals to t, so t is 1 over r squared. So we substitute t by 1 over r squared, so 1 equals to 1 over r squared. We multiply this equation by r squared, and found out that r squared equals to 1. Then we took a root from this equation, and we found out that r equals to the square plus minus the square root of 1. The positive square root of 1 is 1, and the negative square root of 1 is minus 1. It is impossible that the solution is minus 1 because r is a length, and the length must be a positive number, therefore r equals to 1. It is impossible, so we cancel the solution, and we left only with the solution that r equals to plus 1. The radius of the circle equals to 1 unit. Then, according to the second solution, we found out that 5t minus 1 equals to 0, so it means that 5t equals to 1. Then we divided this equation by 5, and we found out that t equals to 1 over 5. According to our definition, t equals to 1 over r squared, so we substitute t by 1 over r squared, and found out that 1 over r squared equals to 1 over 5. Then we cross multiplied this equation, and found out that r squared equals to 5. We took a root from this equation, and finally we found out that r equals to the square root of 5. So we have two solutions that are possible. Either r equals to the negative square root of 5, but because of the fact that r is a length, and the length cannot be a negative number, the solution that r equals to 1 square root of 5 is not possible, so we cancel the solution, and found out that r equals to the positive square root of 5. So we have here two solutions that are possible, either r equals to 1 or r equals to the square root of 5. Then we actually can see in the drawing here that chord BD is not the diameter of this circle. Why? Because it doesn't pass for the center of the circle, that is to say, it doesn't pass for point O. Therefore, chord DB is not the diameter of the circle, and we have the rule that the diameter of any circle is the longest chord in the circle. So the diameter 2r is the longest chord in the circle. Therefore, it must be greater than dB, that is not the diameter. So in conclusion, found out that 2r, the diameter, is greater than dB. Greater than dB, that is not the diameter. Okay, so 2r is greater than dB, and it is given us the equation that dB equals to 2 units, so we substitute dB by 2 and found out that 2r is greater than 2. Then we divided this equation by 2 and found out that r is greater than 1. And because of the fact that r is greater than 1, r cannot be equal to 1. So we cancel this solution, and we left with the only solution that r equals to the square root of 5 units. So in terms of numbers, it is equal to 2.236 units. So repeat again, the radius of this circle, capital R, equals to either square root of 5 units, or in terms of numbers, it is equal to 2.236 units. Okay, thank you very much.